Welcome back to Data Science at Home podcast. I'm Francesco, podcasting from the office of Amethyx Technologies based in Brussels City, Belgium. Today, I want to talk about AI competition and in particular about a big misunderstanding when it comes to AI competition and how to define AI competition today, especially in the last few months. And even more so in the last few weeks, because we have seen this competition growing and growing among, of course, the big players. We don't hear yet from the small players, in my opinion, because they will be absorbed for now. Well, that's what the big players will try to do. But at the end of this episode, I'm quite sure that you will have a different perspective on what AI competition means. And the reason why I'm doing this is because, well, first of all, because the mission of the podcast is to clarify things and, of course, give you my personal opinion. But it's not so personal anymore because I've spent years building AI systems that have to run in production, not just in papers. So the operational question is never which model is the smartest one, but it's more like where does this computation happen? How fast, at what cost, and of course the most important question that nobody asks is who controls the substrate it runs on. These are the questions that in fact define what do we mean by AI competition, and of course define who is in an advantageous position with respect to this definition of winning. Now the answer to that question, or well, to this set of questions, determines, of course, AI competitive advantage at pretty much every level, not just the model. Now we are, in a very simplistic way, competing on which model. A few years ago, it was like, what's the model with the largest number of parameters? As if athletes that are taller are, always faster or stronger. So it was a very simplistic idea about performance in artificial intelligence. So the model, I want to make it clear that the model is in fact an application, and it behaves as pretty much any application out there. The infrastructure is, however, the platform. And platform wars have never been won by the best application, usually. If you think in history, Facebook and Twitter and all the big players, they didn't win because they just were the best options possible, but it's because they had an infrastructure and they could scale, and there were many other good properties, of course, because they won that war at that time. But it was not just because of the application per se. As a matter of fact, you can, if you think, you can replicate Twitter overnight. Does it put Twitter X out of business? No. We could replicate Facebook. Facebook is a blog, it's the first version of Facebook was in PHP. And okay, the next versions were a bit more sophisticated from an engineering perspective because they had to serve billions of people, of users. But per se, there is no tech. There was an infrastructure. So that war was won by Facebook because of the infrastructure, not because of the website or of the applications, right? And so the same thing is happening as an analogy. I'm mentioning this to make that analogy with what has already happened in IT and in history, and that I see also happening for artificial intelligence. So why inference is the real bottleneck? That's the first question I want to ask. Well, training a frontier model requires an enormous amount of compute for even months and millions of dollars. Inference, however, runs continuously for the lifetime of the deployment at scale with latency requirements that cannot be met by routing queries to the other side of the world. So if you think training is a capital expenditure, right? While inference becomes an operational cost. When you start a business in AI and you do inference, inference becomes the operational cost. Operational costs compound typically. So the economics of running AI at scale are essentially dominated by inference, not by training. Training happens only once. As even though it's expensive, of course, I'm not diminishing the concept of training. It's super expensive, but it happens once. It's the one thing, it's the one cost that you have to put at the very beginning of your business, and then you're pretty much done. The rest of the business is going to be about inference costs. Now, as more AI applications move from prototype to production, inference demand is growing faster, definitely faster than training demand by at least an order of magnitude, at least. So the organizations that control the inference infrastructure, of course, control the ongoing revenue and the ongoing leverage. It comes without saying, right? So this is why the major cloud providers are, in fact, more important to the AI economy than the frontier model labs. AWS, Azure, Google Cloud, they are running the inference that generates the revenue. So pay attention to what generates the revenue here. The model labs are suppliers to the infrastructure layer, and suppliers are structurally weaker than platform owners. History comes with this lecture, and we all must learn this. Then there is the second, side of the story, which is the chip supply chain. Now, chip supply chain became geopolitics. I say became, but in fact, it's always been. Since 30 years probably. NVIDIA currently captures approximately 80%, if I'm not wrong, of the AI accelerator market, right? So think about the H100, H200. These are not slightly better or merely better than the competition. They are significantly better with a software ecosystem and tool chain maturity that, of course, compounds the hardware advantage. Remember, CUDA is very, very mature framework, and pretty much no other framework for other chips can enjoy that level of maturity. Now, when it comes to hardware manufacturing, there is two big names here. ASML, for those who haven't heard, they have manufacturing monopoly on the extreme ultraviolet lithography machines. These are machines that are required to produce pretty much the most advanced chips, right? And that's a European brand, by the way, Netherlands. Now, without ASML machines, TSMC cannot produce at now what is 3 nanometer chips and below. Without TSMC, at advanced nodes, nobody produces NVIDIA class chips. That chain, you have to observe that chain, okay? The supply chain for AI compute has two single points of failure. One is at the Dutch company that I just mentioned, ASML, and the other one is Taiwanese companies, labs, and fabs, in fact, they're called, that fabricate this type of chips. So this is not the AI industry problem. This is the IT industry problem, okay? This is the problem of electronics in general. Now, this is a geopolitical problem that the AI industry just made visible, but it was always there. So now people are seeing these things because they became obvious. But in fact, TSMC and ASML are not born yesterday, right? AI made it visible to many because they use AI, and they all of a sudden found that memory and RAM chips cost 2 times the price a few months ago. Now, the US export controls over NVIDIA chips to China are, in fact, in my opinion, the most significant AI policy action of the last, probably 5 years. And they're not primarily about AI, even though they happened with the advent of AI. That coincidence is just temporal. The geopolitical reason that is behind is way beyond AI. So they are about making this supply chain dependency explicit as a strategic instrument. So China's response, which is to, of course, accelerate domestic semiconductor capability at a pace that would have seemed implausible 10 years ago, is the correct strategic response to that kind of leverage. And if you read what happened with that, China said, "Fine, we don't need NVIDIA. We can build our own chips." Now, every major government watching this play out is asking exactly the same question: what is our position in this supply chain? And what happens to our AI capability if access is somehow disrupted? That's the question. Everybody's looking at AI, and the problem is somewhere else, right? When it comes, of course, to geopolitics and potential disruption and sovereignty in hardware and software and technology in general, the European answer is, we don't have a position, we are the customers, which is pretty much, that's Europe. That's Europe at its finest, and will not change that. Now, I want to spend a few words about edge inference and sovereign compute. The centralized inference model, where compute lives in large hyperscale data centers and queries route to it, has a latency ceiling and a sovereignty ceiling. So edge inference moves the computation closer to the point of use, into enterprise data centers, into defense platforms, into telecommunications infrastructure, eventually into endpoint devices you will find in a few years or less, directly into your phone. So this is not primarily a performance optimization, it's more a sovereignty architecture, right? So an AI system running on sovereign infrastructure cannot be externally disabled by, sanctions, by a geopolitical event, or a vendor's business model pivot. An AI system running via API, however, to a foreign data center that you don't control, can be disrupted anytime. In fact, you are the tenant there. You are renting stuff. So the defense establishments that understand this very point are the ones that are building so-called air-gapped inference stacks, procuring on-premise GPU clusters, and of course developing model deployment capabilities that do not depend on internet-connected cloud infrastructure. Now, this is of course very expensive. It's slower to update, operationally complex, subject to obsolescence, and it is also the only form of AI capability that in fact survives the kinds of adversarial conditions that defense planning actually considers. The commercial sector is moving toward edge inference for different reasons. Latency requirements for real-time applications, obviously, data residency obligations when it comes to regulations and private data or personal identifiable information, healthcare, all that stuff, and of course, cost optimization at scale. The result is pretty much the same if you think. Compute moving away from centralized hyperscalers toward distributed sovereign infrastructure. It's always there, like the formula. It's a formula now. So why NVIDIA, ASML, and defense contractors win long term, in my opinion? Well, the model competition produces winners that change, and it's always been like that. Again, nothing new here. The new kids in the room are looking at this as if it's the first time it happens. It's not. And it's sad to say that I'm old enough that I've seen this already twice or three times, I think. Now, GPT-4 was dominant for, 18 months before the landscape shifted, right? You remember that. That is pretty recent. Model supremacy, it was very clear that model supremacy would have been a temporary thing, right? And indeed it is temporary because models can be copied, can be fine-tuned, can be distilled, can be displaced by the next architecture. And I'm just mentioning the things that we have seen in the last 5 years, what really happened. Move the problem to infrastructure, well, that's a different story because infrastructure supremacy is much more durable because infrastructure is physically expensive to replicate. And of course, it takes years to build. So it becomes like the barrier, the entry barrier for whoever wants to enter that market. It's pretty much the Facebook equivalent of The technology can be built tomorrow, but the community, the billions of users who subscribed and who logged in and they have an account there, well, you don't move them away overnight. Like, yeah, okay, you have a better Facebook, a better look and feel, a better platform, whatever. Do you have the users? You don't, right? So that's the entry barrier. And the infrastructure supremacy works exactly the same. It's the physical thing that if you want to enter in my space and become my competitor, well, the bullets are, and the currency you need to play with are infrastructure, hardware, energy, the physical things. NVIDIA's competitive position is not primarily about having the best chip today. It is about having the largest installed base, the most mature software ecosystem, CUDA and stuff, and the deepest integration with pretty much every framework and deployment tool in the industry. Switching costs compound over years. That's another lecture that we learned from IT in the last 20 years. ASML's position is even simpler than that. Simply, there is no alternative. That's kind of a monopoly. The physics of extreme ultraviolet lithography required decades and billions of dollars to develop. The machines cost about $150 million each, but it's not just that. It's the machine, it's IP, it's knowledge, it's know-how, and many other physical things. The supply of people who know how to operate them, that's the biggest lack. It's measured in the thousands globally. This is not a market that a well-funded startup can disrupt overnight. In fact, even a government will find it very hard to disrupt. Defense contractors, this is yet another category. They are positioned a bit differently there, at least up to a few months ago, because these things keep changing as I speak and as I produce episodes. They provide the integration layer, the capability to deploy artificial intelligence inference in environments that are physically hardened, electronically hostile, and operationally demanding in ways that commercial deployment never encounters. That integration expertise is not easily replicated either. So the advantage there is more like on the secrecy or on the type of environment that is very specific to defense, to the defense sector, and doesn't really replicate anywhere else. So what the next competitive phase looks like? Well, I have the tendency to terminate these episodes with what should we expect in the future. So here it is. Again, take my words with a grain of salt. These are personal opinions, probably educated opinions. I'm not doing any guesswork here. I'm just, trying to rationalize on what I know and what I see and what I've experienced in my career. And of course, I'm always happy to know your thought. So please feel free to comment on YouTube, or there is the official website at datascienceathome.com. But of course, the YouTube channel. You are free to post any type of comment, hopefully constructive. And finally, we have a Discord channel, so feel free to jump there. You find all these links on the official website, datascienceathome.com. So the next competitive phase, how does it look like? Well, the consolidation happening right now is not model labs acquiring more researchers, right? It is more hyperscalers acquiring or contracting with the inference chip designers, data center operators, securing GPU allocations years in advance, which, by the way, has increased prices dramatically for end users like you and I. And of course, defense contractors building relationships with whoever controls edge inference hardware, right? So the next, in my opinion, 6 to 12 months will surface which organizations built infrastructure positions or started building infrastructure positions during the current window, and which ones are now paying spot prices to access compute they do not control. The model leaderboard will keep changing. So don't expect that this leaderboard will stay and I don't know, K3 is going to stay the best model, GPT, whatever, or Claude, or these things will move. This leaderboard is doomed to change on a weekly basis even. The infrastructure layer will be harder to disrupt, harder to enter, and more consequential than the application layer that is running on top of that. The geopolitical competition in AI is not about who has the best foundation model, so don't get distracted by that. It's more about who can run inference at scale, under adversarial conditions, on hardware they control. That competition is already underway. And in my opinion, most of the public narrative is watching, well, the wrong race. If you like the show, don't forget to subscribe and follow us. Talk to you next time.